This video has sound. Hopefully everybody can hear it, or they're watching me point at this sign that says that I really definitely want them to hear the sound. This is a lesson for Chapter 11, Section 5 on the areas of circles and sectors out of the Geometry Chapter 11 Study Guide. Now, what is a sector? A sector is a part of a circle that looks like a section that you would cut, the same as if you would cut a piece of pie or a piece of pizza. It's a shape that has a curved portion and then two straight sides. And this little vertex is touching the exact center of the circle. It can be a small piece like that, or it could be a larger piece like this. Basically, if you draw a radius from the center of the circle to the edge, and then another radius from the center of the circle to the edge, and then you just take one of those two sections that you've carved out, either the big section here or the smaller section, that's called a sector. So, the area of a circle, as you might recall, is pi times the radius squared, right? Now a sector, as you can see, is not the full area of the circle, it's only a part. So what we're going to practice now is finding the area of sectors, but first we're going to practice a little bit with the area of circles. So for example, here the area of this circle is pi times the radius squared. The radius has been marked as 4.2. So you'll take your calculator and your square 4.2 first. That's very important that you do that first. So exponents come before multiplication, so that would be 17.64. Then you multiply that by pi. So I get approximately 55.4 square meters. The area of this circle, they actually give you the diameter. They told you the distance all the way across is 9. So that would mean the radius, which is half that distance, would be 4.5. So using the same area formula for circles, pi r squared, first I square 4.5. So 4.5 squared on my calculator. I do that first and I get 20.25. Then I multiply that by pi, and you should get 63.6 approximately square centimeters. Now, number 2 asks you to find the radius, but they give you the area. We can use the same formula, area equals pi r squared. The area, 154, and pi r squared on the other side. What you can do is first divide both sides by pi. So you get r squared is approximately 154 divided by pi is about 49.0197. And then to get rid of the square on your radius, you just take the square root of both sides. So the radius here is about 7 point nothing, 7.0 something. So it's about 7. Now part B is a little trickier. Here we're going to have to find the radius first because our formula for the area doesn't use diameter, it uses radius. So we'll do this same process here, and then once we get our answer to find the diameter, we'll take our radius and we'll just double it. So for example, if number 2 had asked you for the diameter, first we would have done the exact same thing, found the radius, and then we just would have doubled it. The diameter on this circle, for example, is 14. So for this one, I'm going to use the space over here. I'm going to use the area formula for circles. The area is 201. And so I have pi r squared equals 201. I'm going to divide both sides by pi. Now r squared is approximately 63.98. To get rid of the square here, I'm going to have to square root on both sides. So the radius is approximately 7.9988. So we want to find the diameter. So if the radius is 7.9988, then the diameter would be twice the radius. So it's going to be doubling the 7.9988 to give us a diameter of approximately 16 inches. On this page, we're finding the area of a sector. So we talked about sectors over here. They are shapes that look kind of like pieces of pizza, and they can be small or big. Now, to find the area, what we do is we look at proportions. We say the area of this space is proportional to the area of the entire thing. The area of the entire thing would be pi r squared. And the other side of this proportion would be how many degrees the sector is compared to the degrees of the whole circle, which is 360. So that's the measure of the arc. Okay, so hopefully that makes sense. The same amount of surface of this compared to the whole thing is the same as the degrees that this is compared to the whole thing, 360. So if, for example, this is one corner out of a whole circle, which would be 1, 2, 3, 4 of them, then this would be 90 degrees out of 360. Here's another way to write the formula. I like to use this one rather than the proportion concept. Your teacher might use both, or they might favor the first one. I use this one because it's similar to the one we used for circumference type measures in the previous sections. This one basically says this is the total area of the circle. If I take a chunk of that total area that's not the full 360, it's just a certain degrees out of the 360, how much would that be? Total area, this is the part that I want to take out of it. How much would that be? You could even call this, instead of calling this the part, you could say that's the portion that you want. The word portion to me, says, oh, I want half of it, or I want, 2/3 of it, or I want, when you express something as a portion, you express something as how much you want out of the whole thing, like 75% or 15% or something like that. So this fraction represents the portion you want out of the total area of the circle. When you multiply this fraction times the total area of the circle, you get the area of just the part that you want, the shaded portion. So let's try that on example number 2. Now I know it says that they want you to find the area of the sectors. Let's just say we want the area of the shaded part, the shaded sector. So that's this one. So the area of the shaded sector is, I don't want the whole circle, I want just the 63 degrees out of the 360, out of the area of the whole thing. The radius is 5, as you can see here it's marked as 5. So I would say pi r squared, so it'll be pi times the radius squared. Don't forget to square this first. So on my calculator, you could do this a couple of ways. You could take 63 divided by 360 and get a decimal. That's the percentage of the circle that you want. So in this case, that would be 63 divided by 360. that would be 17.5% of the circle. And then you would just write that down, 0.175 for this fraction. And then you'd multiply that by pi and multiply that by 25. Another way to do it, rather than dividing first, is multiplying 63 times pi times 25, and then taking that number and then dividing by 360. Either way, you should get the same answer, 13.74 square units for the area of this section. Now this, remember, is the area of the entire circle. That was 25 times pi. 25 times pi means the area of this entire circle is 78.54 roughly. So does this look, if the whole thing is 78.54, does this look like it would be 13.74? To me it does. It looks like this section out of the whole thing would be about this much out of that much in area. Makes sense. Number 3, find the area of the sector. Well, it's essentially the same question as number 2. Well, again, they want you to find the area of the sectors. I'm going to change this to just finding the area of the shaded sectors. Or the sector. So I want not the full area of the circle. I want this portion of it. The area of the circle is calculated by pi r squared, the radius being 9. I'm going to square this first, very important. Order of operations says we use our exponents before we do any multiplying, so this 9 squared is 81. And so, again, you can do this in your calculator a couple of different ways. You could go 106 divided by 360 and get a decimal smaller than 1, multiply that times pi and times 81 to get your answer. Or you could multiply 106 times pi times 81, take that number and divide it by 360. Either way, you should get 74.93 square feet for your answer of the area of this section that's shaded. So if 81 times pi is the area of the entire circle, 81 times pi, that means the area of the entire circle is 254.469, so about 254 square units. Does it make sense that just this part would be 74.93 square feet? I think so. Just looking at it, if this is 75 square feet about and the whole thing is 254, looks like a proportional amount. This looks like it would be the right answer. Find the area of the entire circle. Oh boy. Okay. Well, this one we still have to use our formula for sectors because we've been given information that has to do entirely with the sector. So I'm going to say that the area of the sector equals the measure of the degree of the arc out of 360 times the area of the circle. So it says that the area of this shaded portion is 22, and it says that the degrees of that arc is 45. So they actually gave us a lot of information. I'm going to change this to just regular A for the area of the circle. So let's see. If I divide 45 by 360, I can start solving it that way. 45 divided by 360 is 0.125. And if I flip that around, I'm going to divide both sides by the 0.125. Then the area of the circle ends up being 176 square meters. The same basic idea applies. Down here they want you to find this area of the entire thing. They give you the area of the sector and the degree of the sector. So the area of the sector equals the measurement of the arc in degrees divided by 360 times the area of the entire circle. So 6.4 square yards is the area of the shaded region, and they're telling me that's an 80-degree portion out of 360 for the whole circle. And again, I'm going to change this to just regular A for the area of circle G. So first I would divide 80 by 360, and that leaves me with 0.2 repeating. And then if I divide both sides by the 0.2 repeating, I get the area of the circle to be approximately 28.8 square yards. All right, so they want to know if they're creating an outdoor space. Well, not necessarily an outdoor space, they're just constructing something in this shape. And they want to know how big an area the shaded portion is. What I see is I see three shapes. I see this large rectangle here. Okay. I see a square right here. How do I know this is a square? Because this distance here is 3 and this distance here is 3. So this is a square. And then I see a half circle right here. So what I'm going to do is I'm going to calculate the area of the entire rectangle. And then I'm going to subtract the areas of these two smaller shapes after I calculate them. So big rectangle, take away this will give me this kind of U shape, the shaded area. So the area of the large rectangle is just length times width. So length is 11, width is 7. If you add 3 plus 4 together, this is 7. So 11 times 7 is 77 square inches. The area of the little square right here is 3 by 3. So length times width on the square, otherwise known as side times side, gives you 9. And then I want to figure out the area of this half circle. The area of a circle is pi times r squared, right? But we want to figure out half of that. So we want half of the area of the circle. So we want half times pi times r squared. So that would be 1/2 times pi. Now what's the radius here? Well, 3, see how that's marked right in the middle? That means that's the diameter. That's all the way across. So half of that is the radius. So 3 divided by 2 gives you 1.5. That would be the radius here on this little half circle. So half of the circle, the area being pi r squared, this will be the formula for calculating that half portion. Alright, so don't forget to square that first. 1.5 squared is, it's 2.25, let's see. 5 squared, yep, 2.25. And then half times pi times 2.25, you can take 0.5 for half, times pi times 2.25, gives you approximately 3.534 for the area of the half circle here. So total area is area of the entire rectangle, 77 units, minus the area of this little blank square here, that's 9, minus this little half circle right here, which is 3.534. So I get an approximate area of 64.47 square inches for the shaded region. right, this shape has two parts to it. It's got a right triangle up here, and then it's got a half circle down here. So the area of the triangle is 1/2 times base times height. The base is 7. The height is 4. So half of 28 is 14. This is a half circle with a diameter of 7. So that would mean that the radius would be half that much, or 3.5. So to find the area of a half circle, half the area of a circle is half pi r squared, right? So that would be 1/2 times pi times 3.5 squared. So on your calculator, you're going to square the 3.5 first, which gives us 12.25. And now we can multiply 0.5 for our 1/2 times pi times 12.25, and we get approximately 19.24 for this half circle area. So then the total shape that's shaded in up there, the whole thing, would be the area of the triangle on the top plus the half circle on the bottom, which is 19.24. So you get about 33.24 square feet. Now the last page here are basically a bunch of advanced questions. So I'm just going to show you my work on those. Here's the first 3. On the first one, I figured out that this shaded portion, if the top part is 209 degrees and the bottom part would have to be 151, because if I subtract 360 minus the top arc, then I get the bottom arc. And so the area of the shaded portion would be the 151 out of 360, that's this section here, times the area of the entire circle, which is pi r squared, radius being 18. Don't forget to square the 18 first, then multiply by pi, and then multiply by 151, and then divide by 360 would be one way to do that. Or you could take this squared and then times pi times 151, or excuse me, times, divide this second. So you divide this out and get a decimal. That decimal times pi times whatever that value was squared. This one was actually not too hard. This one, to find this ring area, I found the area of the larger circle, which if you look at the radius here, for the larger circle it starts here and goes over to here, right? So that's 9 and this is 3.5, so from here to here would be 12.5, right? So that's the radius for the large circle. So I found the area of the large circle by doing pi times 12.5 squared. Square first, multiply by pi, you get that. Pi, you get that. Then the small circle has a radius of 9, so I did pi r squared for the small circle, and I got that. And then if we take the area of the large circle minus the area of the small circle, you get that ring in between, which has the area of 236.4. Here I calculated the area of just one of these sections. The entire circle is divided into 8 equal pieces, so each one of these sections has a degree measure of 45 degrees. And you can see there's 3 of them, 1, 2, 3. So I multiplied that times 3. So these 3, if you put them together, would create a section, you literally push them together, would create a section that's 135 degrees across. And that is the area of the circle portion that I want. I want a portion out of the area of this circle, which has a radius of 13, of 135 degrees out of 360. So area portion that I want. So I took this squared, which is 169, and then multiplied straight across is one way to do it. 135 times pi times 169, and then divide by 360. Or take this fraction, square this, and then multiply those three pieces together. Either way, you would end up with 199.098. And then the last one's pretty tricky. On this one, I did almost the exact same thing as I did up here. I found the area of this entire ring by doing what I did here. The radius of the large circle goes from here to here. That was 12 feet. And the radius of the small circle was, hold on a second. That wouldn't be 12, that would be 5, because this is 5, isn't it? Okay, so that'd be 5, that'd be 7. So let's see what the actual answer is if I read the diagram correctly. So this is 7 and then this is 5. Let's get some new answers, huh? Alright. So, just like we did up here, I'm going to, oops. This is the diameter, not the radius. I think that was my mistake. I assumed that was the radius, but I don't believe it is. I think that's 5 and that's 5 and this is 10. So, assuming my reinterpretation of this question is correct, 7 squared is 49, and 49 times pi gives you 153.93804. And then if this small circle has a radius of 5, that would be 25 times pi for the area. And that gives me 78.53981634. And then if I subtract the area of the whole circle, the large one, minus the small circle, so if I subtract here, 53.93804 minus my other answer, I get 75.398 approximately when I subtract here. Okay, now that is the area of this ring if the whole ring existed. That's what I did up here. Is I found the area of the large circle minus the area of the small circle, and I found the area of the ring. But here, I don't have the whole ring. I have half of that ring. So what I'm going to do now is I'm going to take the area of ring, that's this, and I'm going to divide it in half. So 75.398 and so on. If I take half of that, then I just get this half, not the whole ring. So that would be a different answer. There we go. 37.7 square feet.